All right, this lecture is going to be an introduction to Plots.jl, the kind of standard plotting package in Julia. So first of all, Plots.jl is not installed by default when you install Julia. So it's an extra package that you have to install, and the way you would do that is either from the Julia REPL, you would type this command, just or this line, right? So using PKG and then PKG add plots. Or from the Julia REPL, you can enter the package manager with the bracket symbol there, and then just say add, type add plots, and then either one of those will install plots.jl. Also, just a comment, most Julia packages are named with the extension JL, so plots.jl, differential equations.jl, and that makes it really nice for search engines, right? So if you're looking specifically for some keywords or how to do something in plots in Julia, make sure you search plots.jl. That should take you where you need to go. So let's go ahead and start. We're going to basically look at how we use this through some simple examples. So first thing we can do is just pass in an array of numbers, in this case integers, and it'll plot those. And by default, it puts the legend on the plot. And by default, it just labels the lines Y1, 2, 3, 4. Of course, we can change all of those by adding attributes to the plot, so that we have full control over the way the plot looks. You can basically recreate any two-dimensional plot you've ever seen before with plots.jl by just manipulating the attributes. And so, here's an example of how to do that. In this case, we're just doing a couple of things. We're going to add a label. So we say X label, and give it some numbers there, and then we're going to turn the grid off in this case. So the grid was on by default, and we'll turn it off. A full list of attributes of all the things you can change on the plot are available here. So if we go to the documentation, look at attributes, there's kind of an overview. Then specifically, if you look at the plot attributes, there's many attributes for plots and other things we'll look at. Series. This basically defines, the different types of plots, bar plots, histograms, other things like that, how the plots look, subplot attributes, other things like that. So you have full control here on the way the plot looks. So I'll leave that up to you for further explanation or exploration. This is how you add multiple lines to a plot. So when you establish the first plot, and in this case, I'm go ahead and labeling the line itself and setting the line color. So in this case, we use, instead of a string, we use a symbol in Julia, which is, you can kind of think of is equivalent to a string. In this case, and you can see that for line color, it accepts either the symbol blue or strings. So I could also have used a symbol, so like colon black there. In each case, I'm labeling these. Another thing to note about the attributes is that as long as you write enough of it to be unique, you don't have to write out the whole label. So this stands for X label, but you can see I wrote just a shorthand version of it, and so that put the label down here, T. In this case, I'm plotting, T as a function of, so I set this lens space here. That's on the x-axis, and then I plot T and T squared and T cubed. And again, I'm just labeling them all, and by default, the legend is shown, right? So just an example of how to, set some different attributes for the plot. We can also use and or create themes. So there's several built-in themes. You can see them here. There's a list of all the built-in themes. But in this case, obviously, I'm using a black theme, which would be useful if we were, say, publishing to a web page that had a dark background. So this is the same plot before. The only thing I did here was I ran this function theme using the symbol dark, and this by default set these. Now we can also add attributes to the theme function, and those will become the default settings for all plots that follow. So in this case, in addition to setting it dark, if I set the grid to false, then you see the grid has disappeared, and any plot that I create after that, unless I run another command theme to reset things, won't have any grid lines are in the background. So we can do subplots and layouts. In this case, I set the theme back to default, and I set the default label to nothing. So in this case, it won't show the legend for those plots. And here I'm showing how to create some subplots or layouts. I use this layout macro, which takes as an argument a nested set of arrays. And what you call each of the plots doesn't matter. So in this case, I'm just saying A, B, and C. And the syntax here basically controls the width. So for the plot A will contain the 60% of the width, and then that'll be followed by another array B and C that'll be stacked plots taking up half the height in both cases. So I create the three plots. The first is a scatter plot with two arrays, plotting the two arrays. So permeability is a function of porosity, and I set some labels there for the plot, and that's what you see here, as well as two histograms, one for the porosity and one for the permeability. And then after I set up this layout, then I would just call this plot command, passing in the three arguments P1, P2, and P3, which I defined to be these three plots, as well as the layout there. And so that pretty easy way to create, have a lot of control over the way a subplot looks. We can also do contour plots. So in this case, contour F implies a filled contour plot. It does by default have lines that separate, black lines that separate the contours. In this case, I've set the line width to 0. That gets rid of those, and you can see this. So the arrays X, Y, and Z. Z is on a grid. X is just, it's not the full grid, but rather just the X components. So it's just an array that contains the components along the X direction, as well as Y it's just an array, a short array. So in this case, I think the total grid is like 22 by 54. And so there's like 54 in the X direction, 22 in the Y direction, and then Z is a two-dimensional array that's 22 by 54. I also set the grid to false on this. The final point is what you don't see here is in the Z array, this area out here, they're actually points, but they're set to nans, floating point, not a numbers. And when you have not a numbers in your plot, then the default way to plot that is to plot it as white spaces. So you see that here. And this is like the representative of the depth in a petroleum reservoir here. We can also do surface plots, but if we just pass the X, Y, and Z arrays to plot and set this to surface, then you see we get this kind of funkiness, and that's because the default backend, which is a backend called GR, doesn't interpolate well in the surface plot. And so for that, we probably want to use a different backend. And in this case, we can use the Plotly backend. So we specify that by running this command, plotly.js, this function. And then we get something that is not only interpolated very nicely, the service plot's interpolated very nicely, but it's also interactive. So this is Plotly's made for web browsers. So in this case, we can pan around, we can inspect the various aspects of the plot. We can take a snapshot to download a PNG. We can reset the view. We can do other things here. So just take a look in the documentation of the different backends and their features to understand, what the utility in each of these are.